Hello, today we're going to be doing some more route matrices, and these are going to be two-step route matrices. Please make sure you've watched the previous video, otherwise this won't make any sense at all. Alright, from the last lesson we looked at an example with 4 towns and we got this one-step route matrice on the right, which is pretty straightforward. But what do we do if the question wants you to do a two-step route matrix? Well, a two-step route matrix is the exact same idea, except you have to take exactly 2 steps. You have to go down 2 roads. You can't do one, you can't do none, you must take 2 roads. So, to start things off, if we look at from A to A, will our answer change? So, from A to A, starting from A, going to A, we could go to B, and then we could go back to A. So, if we have to take 2 steps, we could go from here, and then back to here. Or alternatively, we could go from A to C and then back to A. So there are 2 routes going from A to A. Alright, A to B, there's only one way you can get there with 2 steps. You can go from A to C and then go from C to B. There's no other way for you to get to B in 2 steps. If you start at A and go to B, you have to take one more step, so you'd have to get off it. So the only path we can take is A, C, B. That is the only path to get there. Next, A to C is 1. Same idea. You'd go A to B and then B to C. And finally, A to D is 1 as well. And the only way you can get there is going from A to B and B to D. So just remember, you must take 2 roads. You must take 2 steps in a 2-step route matrix. Alright, next one, from B to A, there's only one way, and that would be from B to C and then C to A. Next one, B to B, there are 3 possibilities here, because you can go B, A, B, B, C, B, B, D, B. B to C, only one possibility, and that's B, A, C. There's no other way for you to get there in 2 steps. And finally, B to D is 0. It is not possible for you to get from B to D because you have to take 2 steps. No matter what you try, you will not have enough steps to get and finish at D. Next row, C to A is 1, so C, B, A, and then C to B is also 1, C to A to B. That's the way to get there. Next one, C to C is 2, so C, A, C, and C, B, C. That's the only way you can get there. And finally, C to D is going to be 1, and that would be C, B, D. Okay, last one, D to A. There's only one way to get there. You go D, B, A. Next one, D to B is not possible because you can get there, but then you have to step off it, so it's not going to happen. D to C, you can go from D to B and then to C, so there's one way to get there. And last but not least, D to D, go D to B to D. And that's our complete matrix on the right over here. Alrighty, we've looked at loops in the last video, but just be aware, loops with 2-step matrices get very complicated very quickly. You really need to check all directions of a loop. Let me show you what I mean. Okay, so I've made this graph over here, A, B, and C. I just wanted to keep it simple so you can understand what's going on. From A to A, there are 2 paths, so you can go down and then up and then right and then back. We're pretty good with that. A to B, we could go across to B and then go along the top. That's one path. Alternatively, we can go across and then go from underneath here. So there were 2 ways to get from A to B. A to C is not possible because we can get to C, but we have to step off it. For the next one, B to A is 2 because you could go around the top of the loop and then left. Alternatively, you can go at the bottom of the loop and then left. Now, B to B is 5. How the heck is it 5, you might be wondering? Well, let's try to work it out. First of all, starting at B, you could go along the top and then you can go along again. Just go 2 loops to the right, clockwise. That's one path. Alternatively, you could go anti-clockwise twice. That's 2. What if you went clockwise and then changed your mind and went back this way? That's another one. Or you can go anti-clockwise and then clockwise. That's the 4th one. And then from B to A and then back to B is the 5th one. So just be aware, when there's loops involved and there's two steps, it gets pretty crazy. So just be super vigilant when you're trying to work this out. Make sure you try all the combinations of a loop because it gets pretty hectic. Alrighty, next one. From B to C, there's only one path. We go B, A, C. Next one, C to A, we cannot do. We get to A, but then we cannot step back. So we're stuck. C to B is going to be 1. So C to A, then A to B. And the last one, C to C, is 1 as well. We go from C to A and then back down to C. All right, everyone, here's the challenge. Create a two-step route matrix for the following diagram. Remember the rules regarding loops. So if you could just pause the video, do the very best you can, try to see if you can get this matrix correct. Alrighty, let's see how you went. So first of all, A to A is 2, pretty straightforward. So we go A, B, A, or A, C, A, nice and easy. Next one, A to B is 3. So we can go across here and then clockwise. We could go across here anti-clockwise, or we can go down and then across here. Next one, A to C was 0. There's no way to go from A to C if you have to take 2 steps. Next one, B to A is 2. We could go clockwise left or anti-clockwise left. Next one, B to B is 5. It's pretty much identical to the last example we did. Hopefully you understand all those 5 routes. And then B to C is 1. You can only go from B to A and then A to C. Next one, C to A is 1. C to B is 3. So we can go up and then right. We could go along this line clockwise, or we can go along this line anti-clockwise. And finally, C to C is 1. That's just going up and down again. So you might be wondering, is there an easier way of calculating the two-step matrix? It seems like a lot of work. If we had like 4 or 5 vertices, it gets pretty out of control. How can we do this faster? Well, if you square a one-step matrix, what I mean by that is you times it by itself, you will end up with a two-step matrix. It's really cool. So if you multiply your one-step matrix by itself, it'll give you the two-step matrix. Alrighty, let me show you what I mean. I'm just going to fly through this example. Feel free to pause it and work it out if you want in your own time. But we're going to make a one-step route matrix, then we're going to make a two-step route matrix, and I'll show you how this works. So very quickly, if we work out all 3 of these, this is our one-step matrix. If we worked out the two-step matrix by following the rules of 2 steps, we get this answer here. Now, this answer on the right is going to be important. We're going to see if we can get that just by timesing this by itself. Let me show you what I mean. All right, if I take the one-step matrix I had from the previous diagram and I times it by itself, we're going to get the exact same dimensions, but if you multiply this out, you'll end up with the two-step matrix from the previous example. So if you take a one-step route matrix and you times it by itself, you square it, you will get the two-step route matrix that we worked out before. So to keep it nice and simple, if your calculator can multiply matrices, you can always check your two-step matrix by squaring the one-step matrix. Alright everyone, thank you so much for watching. Hopefully that makes sense. If you have any questions, let me know down below. Apart from that, have an awesome day.